let us now discuss about the various kinds of servers and middlewares. So we are going to discuss in this session application servers, middleware, licensing models and software asset management. Let us explore two crucial components of modern IT infrastructure first, application server and middleware. These technologies play essential role in supporting and managing complex software application and ensuring smooth communication between different software components. Let us first understand what is application server. Application servers provide a platform for developing, running and managing applications. They act as intermediaries between end users and backend database or services offering a range of functionality that enhance application performance and scalability. The function of application servers include handling the business logic of application, manage user session and provide access to the database and other backend services. They also ensure scalability by managing multiple instances of applications and balancing the load among them. The main features are support for multi-tier architecture, transaction management, load balancing and security feature. Some popular examples are Apache Tomcat, IBM WebSphere, Microsoft IIS and JBoss. So let us understand now the application software in detail. Today, we will delve into what an application software is in this particular session. How does it differ from web server and explore the various types and example of web app servers available in the market. So, what is an app server or application server? Let us understand that in a simple word. An application server, short for app server, is a software framework for platform designed to manage and deploy web application and services. It acts as an intermediary between users and backend databases or resources handling key functions like business logic, security, and data access. Essentially, app servers play a pivotal role in web application development and delivered by processing client requests and generating dynamic content. Now let us understand where do we use web or app servers. Application servers are versatile tool with several important functions in web application development and deployment, including handling client request, processing incoming user request and generating response based on the application logic and data is a main benefit. The second use is managing business logic, executing the application core logic, facilitating data manipulation and implementation based on the standard operating process of the business function. Third feature is database access. It interacts with database to retrieve and update data required by the application. Next feature is session management. It maintains user session and state information to provide a personalized experience. The next feature is security enforcement. It enforces security measures like authentication and authorization with user ID and password to protect sensitive data and resources. Load balancing. It distributes incoming requests among the multiple server or user trying to access the application so that it ensures without interruption, without denial of services for the optimal performance scalability. Next feature is caching. Caching frequently access data or resource to improve application performance and reduce database load. Other feature is integration with other services. It enables communication with external services or APIs for seamless integration with third-party functionalities. It also allows you to handle various transactions. It ensures data integrity and consistency during complex operations. So these are certain important features which we were discussing about the application servers. Now let's move to some more features which are identified with these servers, like web services. Web service deployment is one of the very important features of application servers. It basically allows to host a web service that facilitates communication and data exchange between different applications. Now let us understand how is an application server different from web server. A web server handles HTTP requests from clients such as web browsers and servers. The static content like HTML image and file, it upload that on the request from web browser like Chrome or Internet Explorer. It acts as a bridge between the client and web application. In contrast, app server execute the application's logic, process data and generate dynamic content based on user input, not on the browser request. While the web server delivers static content, the app server or application server provide dynamic functionality needed for interactive web application. Together, they ensure that website and web application run smoothly. Now let us discuss different type of application servers. Application servers come in various types, each designed for specific needs and technology stacks. Broadly, there are three main types of application software. Active servers. These app servers actively execute server-side script and interact with database to generate dynamic content. They handle business logic, process data, and provide real-time response. Web information servers, specifically designed to handle requests related to web content and information retrieval, is the work of web server, application server. They manage database and deliver dynamic pages with relevant information on a website. Third is component servers. This is also known as component-based application server. They host and manage reusable software components. These components can be dynamically assembled or reassembled and executed to provide specific functionality, promoting the differentiality and code reusability. That means one single software can be customized and modified by different clients. Example of application servers are, here are some commonly used application server which are tailored to specific language or framework. Java EE App Server. It supports Java Enterprises Edition application with a range of Java-specific feature. .NET Application Server is one of the popular example. It facilitates and deployed and execute of .NET application for Microsoft framework. The third example is PHP Application Server, geared toward hosting PHP-based application popular for PHP-developed website and web apps. The fourth example is Node.js Application Server. This server optimized for running applications built on Node.js runtime, ideal for real-time and data-intensive applications. The next one is Python Application Servers. It supports hosting Python-based application often used with framework like Django or Flask. The sixth example is Ruby on Rails App Server. It simplifies the deployment process for Ruby-based web-based application. Seventh example is Apache Tomcat, a lightweight Java-based application server commonly used for hosting Java Servlet and Java Server Page JSP. The eighth example is Microsoft Internet Information Services IIS. It functions as application server for .NET application and other web technologies on Windows servers. Next example is Wildfly, commonly known as JBoss. It is an open source Java EE application server designed for enterprise level application. The next common example is Nginx. This is primarily known as web server but can also function as an application server, especially for serving static content or acting as a reverse proxy server. Now let us discuss about middleware. So what is middleware? Middleware is a type of software that acts as a bridge between different application, database and system. It enables communication and data exchange between software components that were not originally designed to work together. The main function of middleware is to facilitate seamless integration of different systems, provides communication protocols, and ensure that different applications and services can work together smoothly. It often handles tasks such as messaging, authentication, and data translation. Let us discuss different types of middleware. The first one is message-oriented middleware or MOM. It handles communication between distributed applications through messages. Example includes RabbitMQ and IBM MQ. Next category is object middleware. It manages interaction between distributed objects such as CORBA, the Common Object Request Broker Architecture. Database middleware is the next category. It provides a layer of abstraction between application and database such as JDBC, Java Database Connectivity. The next category is web middleware. It supports web-based application including web server and application framework. Popular examples of these are Apache, Kafka, IBM, WebSphere, MQ, Oracle Fusion middleware, and Red Hat JBoss middleware. So, middleware is crucial technology in today's software ecosystem. It serves as the bridge between different applications and enable them to communicate seamlessly and efficiently. This connection allows for integration of diverse technologies, tools and database into a single system that offers a cohesive service to the users. Why is middleware important? Middleware began as a solution to integrate new application with existing legacy system without the need to rewrite older code. Since 1980s, it has evolved into a vital tool for communication and data management in distributed system. Middleware simplifies the design process for developer by handling connectivity between various software components, allowing them to focus on core business logic and features. Without middleware, developer would need to build complex data exchange modules for each components, which is especially challenging in modern application. Cases of middleware, let us discuss that. Middleware is versatile and is used in various domains, including game development. Middleware acts as a game engine facilitating communication between various images, audio, video server, making game development more efficient. Electronics. In electronics, middleware integrate different sensors with controllers through a common messaging framework. Software development is the next example. Middleware provide a standard API application program interface to integrate different software components, hiding internal complexity and managing data input and output. The next is data transmission. It ensures reliable data stream for video and audio streaming. Distributed applications. Middleware connect front-end application with back-end system, ensuring smooth operation of distributed software program. Middleware architecture. Let us discuss that. So middleware architecture consists of several components that create a data pipeline between applications. These components ensure data compatibility and effective communication. The key components include Management Console. It provides an overview of middleware system activities, rules and configuration. Next component is Client Interface. This is the outer layer that communicates with the application, allowing interaction with the database and other services. The third component is Middleware Internal Interface. This glue that binds various middleware components, allowing them to function cohesively. The next component is Platform Interface. It ensures that it is compatible with different operating systems. Contract Manager is the another component. It defines how the data can be exchanged, what are the rules for that, ensure compliance, sending alert for rule breaches. The other component is Session Manager. The Session Manager set up secure communication channel and record all communication data actively. The other component is Database Manager. Database Manager integrate with various database type as required by the user and the application. The next component is Runtime Monitor. Runtime Monitor monitors the data movement and report unusual activities. Now let us understand how does middleware work. Middleware abstract the communication process between software component. For example, front-end application only interact with middleware, not needing to understand back-end system specification. Messaging framework like JSON, REST API, XML, and SOAP standardize data exchange between components across different platforms and languages. So, example of middleware. Let us understand that. A common example is a web server acting as a middleware between a website and a backend database. When a user submits a form, the request is sent in XML or JSON in the web server. The server processes the request, retrieve information from the database, or communicate with other service while managing various protocols. The other function of middleware is beside connecting the various application, middleware also provide secure communication channel. Security, ensuring sensitive information is safely transferred between distributed application. It manages the traffic flow. It prevents overloading of specific application or user request on a server. It automates response. It sort out and filter results before sending them to front-end application. Now let us understand what is platform middleware. Platform middleware support application development by offering managed tools and resources. It facilitates the sharing between and transfer of resource between application. Example includes runtime environment, like the Java runtime environment, which allow application to run on various platforms. Web servers, programs like Amazon Lightsail that manage web server hosting. Content management system, the software like WordPress that manages digital information and allow people to create a blog or a website. Containers, it allows the bundles of application codes and resources managed by tools like Amazon ECS. Let us understand now the software licensing model. Now, we will explore different ways the software can be licensed, which determine how it can be used, shared and distributed by companies and by individuals. The first category is proprietary licensing. Proprietary software is owned by an individual or an organization and its source code is not available to the public. User must comply with the term set by the owner or the company, including restriction on modification, redistribution and sharing. The main feature of this softwares are, or this ownership of licensing are, the software source code is closed, not accessible to the user. There is a restriction on the user that they can't modify and distribute this software without the permission of the creators. The cost, it involves a one-time purchase fee or it can be a subscription model. Example, Microsoft Windows, Adobe Photoshop or Adobe Creative Cloud or iTunes. The next category of licensing is freeware. Freeware is a software that is available for use at no cost. However, while it is free to use, the source code is not available for modification, and users are generally not permitted to modify and distribute or share this. The main feature is the cost. It is free to use, source codes not available for modification. There is a restriction that means limited to the terms of use provided by the creator. Examples, Skype, Adobe Reader, and etc. The third category is shareware. Shareware allow user to share the software for free for a limited time. After the trial period, users are typically required to pay for continued use or unlock additional premium feature. Features under the trial period offers very limited features. But in order to use the premium feature, it uses a payment method. The user need to update and upgrade and pay while using the software and access the full premium feature. The source code is not available for modification. Some examples are WinRAR, Adobe Creative Suites, and Creation CRM. Open source software. Open source software provide user with access to modify the source code, allow them to enhance and redistribute the software. It encourages community collaboration and transparency. The main feature of these software that source code are available to anyone for modification and redistribution. It is a community-driven software which is often developed collaboratively by the community of contributors for the societal use. The costing is typically free to use, though some project may offer paid support. Examples, Apache, HTTP server, LibreOffice, Mozilla Firefox. Public domain software. Public domain software is owned by an individual or organization and is free for anyone to use. So it is actually not owned by anybody. It is not owned and licensed by anybody. Anybody can modify, use and distribute without any restriction. It is often released by its creator into a public domain. The main features are there is no restriction, completely free to use, modify and distribute. Nobody owns this software, no legal claims or ownership by any entity. As I said, it is free. Some examples of these software tools which is used for academic research software are, for example, you can go to the web application and use certain application software which is just free. Then the next model is freemium model. Freemium software is available for free, but user can pay for additional feature or services or enhanced functionality like Canva. This model is commonly used for software and online services. The basic version is free without any core feature, but the premium feature need to be upgraded and these additional premium features are not available for free. Revenue generated from premium upgrades or these kinds of things are from subscriptions. Example, Canva, Dropbox, and many other like that. The other kind of a software licensing model is subscription-based licensing. Subscription-based licensing allows user to pay a recurring fees to use this software. This model often includes ongoing updates and support as part of using this particular software on a regular basis on the basis of monthly or yearly subscription. The main feature are recurring fees. The fees can be paid monthly, annually, or based on usage. It includes accessible updates and new feature. It also uses access, which require active subscriptions for continuous access. Examples: Microsoft 365, Adobe Creative Cloud, or Salesforce CRM software. The eighth type of licensing is called site licensing. Site licensing provides organization with the right to install and use the software on multiple machines within a specific location or a physical demographic region which within the organization. That means within the premises. It offers a cost-effective way to license software across a large number of users. The main feature is coverage. It allows the multiple installation on multiple computers within an organization. And the cost is very effective. It is most cost effective for the larger organization. The management simplifies licensing management for multiple users for same software. Examples: many enterprises software solution use Oracle or IBM software. Let us now understand software asset management and why it is important, how it is helping organization managing their software asset effectively. So as I said, hardware and software is an asset to the company, a critical resource. So what is software asset management? Software asset management is the strategic approach to manage, optimize an organization's software asset. It includes tracking, managing, and controlling software usages throughout its life cycle to ensure compliance, optimizing cost, and enhance productivity. This particular software management involves the administration of software licensing, usage by multiple users, and compliance adherence. Optimization of these resources is effectively used. It is cost effective for the company. It also helps companies to maintain and adhere to the license agreements and also maintain and manage the legal requirements for the software usages. Let us understand why software asset management is important. Effective software asset management is crucial for several reasons. It helps organizations avoid legal and financial risk. It improves efficiency and support strategic decision making. The main benefit is cost saving. It reduces unnecessary spending on unused or redundant software license. The compliances. It minimizes the risk of non-compliances with software licensing agreement. Operational efficiency. It enhances software deployment and usages across the organization. Strategic planning. It provides insight into software usages, trends, and needs. Key components of software management are, let us discuss this. The software asset management involves several key components that work together to ensure effective management of software assets. The first one is inventory management. Like how we manage the inventory of products, we need to manage the inventory of software. It means track and document all software assets within the organization. It involves regular audits, maintaining up-to-date records, and categorizing software. It also involves license management. The license management means managing software license to ensure compliance with license agreement. It involves tracking license type, usage right, renewable dates, and compliance status. Usage tracking. It monitors and analyzes software usage across the organization, which involves collecting data on software installation, user activities, number of users, and resource utilization. The next one is vendor management, which involves managing relationship with software vendors and suppliers, like negotiating contracts, managing support agreement, and evaluating vendor performance. Compliance management software. It ensures that it adheres to the software licensing agreement and regulatory requirement. So software asset management involve these activities of conducting compliance audits, managing license management, agreements, and addressing compliance issues. Optimization. Software asset management identify opportunities to optimize software usages and reduce the cost, which also involve reallocating license, consolidating software, and implementing cost-saving measures. Implementing a software assessment management program is involving several steps to ensure successful management of software assets. Let's now look into the assessment of these software asset management, which involve what is the current state of software assets, what are the best management practice in that, which also involve conducting initial audit, identifying gaps, and defining objectives. Planning of software assessment management, which involve developing software assessment management strategies and planning for implementation, which also include setting goals, defining processes, and allocating resources. Now, how do you execute this? Implementation of software assessment program according to the plan is the execution, which involve inventory management of software, license tracking, and compliances monitoring. Monitoring and review is a very important process and steps in software assessment management, which includes continuously monitoring and reviewing the software assessment program to ensure effectiveness, which includes conducting regular audit, assessing performance, and making improvement. It is must that the training and awareness program should be included, which can educate the staff on software assessment management practices and policies, which also include providing training session to employees, creating awareness campaign, and encouraging adherence to software assessment guideline. Now let us discuss what are the common challenges a company face in software assessment management. While software assessment management provides many benefits, organization may face several challenges in its implementation and management. These challenges are complex licensing agreement, managing diverse and complex licensing term, inaccurate inventory, maintaining accurate and up-to-date record of software assets, compliance risk, ensuring compliances with ever-changing licensing agreement and regulation. The third challenge is cost management, balancing software cost with organizational need and budget.